So thinking about this issue of steelhead and what problems they're experiencing here, they were first listed under the Federal Endangered Species Act in 2007. That listing was revised or renewed in 2014. They're still listed as threatened. But we were seeing problems here in Hood Canal, the water body behind me, as early as the late 1990s. So around 1999, NOAA and Long Live the Kings, the Skokomish Indian tribe, Washington Department of Fish and Wildlife, and others decided to try a novel technique to restore steelhead populations, because we were in a situation where in a river like the Hamahama River that may have had up to 1,000 steelhead returning or more, we were down to 18 adult steelhead returning to the river, which was a crisis. And this was before they were listed under the Federal Endangered Species Act. We didn't know why that was. The habitat on at least the west side of Hood Canal is really quite good. A lot of it's in the national forest and big national park. Fishing has been curtailed for steelhead here, and there's no production hatchery program for steelhead in existence now either. So the impacts were significantly lower here, and we couldn't understand why they were down. So a strategy to recover them was to employ a novel hatchery recovery program where we would sample adult steelhead in the environment, look where they're spawning, mark their reds, come back after time had expired, and collect their fertilized eggs. So we knew that the offspring of these fish are fish that could fertilize eggs in nature. Take them back to a hatchery, rear them for a period of time, low growth rates and low densities, release most of those fish back into the environment as 2-year-old smolts ready to head to sea, retain a small portion of the fish for adults to adulthood, and release them back into their native rivers when they're ready to spawn. So this was thought of as an approach that would increase the population against whatever the insults were that were causing the population to decline, and essentially keep it from going extinct. And what we found is that we were able to get the population numbers up by about a factor of 10, but we were looking for a factor of 100 at least, and we weren't very close to what we considered recovery targets. And we started looking at, given that the habitat in the canal was pretty good in both the marine environment and the watersheds, we started looking for other factors. And one of the things that we did was to put acoustic transmitters in steelhead smolts that were going into the marine environment, and then track them using receivers throughout Hood Canal and out into the Strait of Juan de Fuca. What we found there is that there seemed to be a significant amount of dropout active transmitters around the Hood Canal Bridge. In other words, steelhead mortality seemed higher in the general vicinity of the Hood Canal Bridge, which is the infrastructure you see behind me here. It floats on Hood Canal across 83% of the channel. There are open spans on either end, and it goes down 15 feet into the water. So this was interesting to us. In general, though, we were losing about 85% of the steelhead in their first 2 weeks of marine migration. If you look at mortality throughout the entire extent of Hood Canal and out to the middle of the Strait of Juan de Fuca, that was a pretty high mortality rate. So there was a significant amount of dropout of acoustic transmitters in steelhead around the bridge here, but there was also significant loss before and after the bridge. So what we did is thinking that, well, what is going on at the bridge? Got some funding from the state, the Washington State Legislature, and Senator Kristen Wolfus from Kitsap County provided funding for us to do an intensive study for 2 years at the bridge to look at what might be impacting steelhead survival, and if it was in fact right at the bridge where it was occurring. So we were looking at the distribution of steelhead vertically in the water column, horizontally across the face of the bridge, extending out from the bridge in 2 directions. We also had temperature sensitive transmitters that would read if the temperature of the probe went up, indicating perhaps predation by a warm-blooded animal. And we did that for 2 years in a row. We also looked at things like noise at the bridge and lights, were those causing problems for steelhead. And what we found 2 years in a row is that around 50% of the steelhead perished at the bridge. And in almost every case, when a transmitter eventually stopped transmitting, the swimming behavior associated with that transmitter would change. It would go from being right at the surface like a juvenile steelhead to moving up and down in the water column. In many cases, the temperature went way up, indicating predation by a warm-blooded predator. So it appears that predation is a significant source of mortality for steelhead here in Hood Canal, and we think in other places in Puget Sound. We think that it is a warm-blooded predator like a harbor seal and or a harbor porpoise, or harbor porpoises and harbor seals that are causing the mortality, and that there is something to do with the structure of the bridge floating down into the water for an active surface migrator like steelhead that is causing them to get caught at the bridge and held up and then collecting there, more susceptible to predation. And in fact, visual observations have indicated that harbor seals corral juvenile steelhead into the corners of the bridge and have increased predation there. Putting the kind of mortality that we're seeing at the Hood Canal Bridge for steelhead in context, at 50%, that is a number that's equivalent to mortality on juvenile steelhead leaving the Snake River Basin that is caused by 4 lower Snake River dams as the fish go out and their reservoirs, and 4 lower Columbia River dams and their reservoirs. So the cumulative impact of 8 dams is the same as the impact of the Hood Canal Bridge, and that's really significant. So we have a challenge here, and we need to do something about it. In order to address the challenge that we see for steelhead at the bridge, we received more funding from the Washington State Legislature, and right now we're devising devices that we can put in the corners of the bridge to allow steelhead to pass more quickly past the bridge, hopefully going under the open spans on the end and not being caught there swimming back and forth in the bridge and being subject to predation. If we can increase the survival there by even 10%, that would be a significant impact. If not, if that doesn't work, then maybe the only solution here is to replace this bridge with a design that allows fish to pass unobstructed underneath the bridge. That's a very expensive proposition, so we're hoping that in the meantime, while we come up with a design and wait for other transportation projects to get taken care of, that these devices or structures that we put on the bridge will increase survival significantly. So some of the impacts that we worry about for steelhead are things like high temperature in our rivers, pollution in our rivers. We have steelhead in the Nisqually River that have high concentrations of flame retardants. We are concerned about lack of habitat, and wild steelhead will rear in freshwater for 2 years before going to sea. So for the entire year, the river has to be in the kind of condition that can support steelhead. We have to have cool running water. We have to have places for those fish to hide. We have to have insects and food for them to eat. And so we really need to start thinking about how we take care of our riparian areas